In this video, we will learn to get the right children, children of any node, as well as we will learn how to get the parent of a node. So this will I have already explained the formulae related to these things in the past videos. In the current video, we will do the same thing but using a C program. So let us see the related C program. Here I type and I take the header file, include std io.h, and thereafter int main is the function from where the running of this program will start, and here I take two variables I and n because we visualize the array as a heap. So, and array, in any array the elements are stored with their respective index number. So I take the variable I, and here the second variable n is for the size. Now we show a message to the user so that he can enter an integer for the size. So I type here enter the size, and thereafter we have to scan that number, that integer. For that we use the scanf function, and a scanf function stores the value at an address. For that we use %n. Now as soon as we get the size, it's time to declare the array, and here is the array name and n is the size. And you must remember that only at the time of declaration the number inside the square bracket stands for the size, but after that we use the same array name and write any number inside that square bracket that indicates index number, not the size. So I declare the array. Now it is time to get the values for the array, for the elements of this array, and for that I again show a message to the user, and here I type the array elements are, and the array elements are at a distance 1 starting from 0 and ending with size -1. For that we have to use a loop I equals to 0. This is the reason why I have taken this variable I. I will go up to n-1, so I here will be less than n, the condition. And since the indices, the elements and their indices are at a distance 1, the consecutive indices are at a distance 1, so I plus plus here. And thereafter to scan the values for the elements of this array entered by the user, we use again the scanf function, and here will be %d because I am going to take the integers for the elements of this array. And again the values are stored. Values will be provided by the user, and those values are stored at different addresses. For that I use ampersand, and those variable for this those values is ai, where ai where I varies from 0 to n minus 1. So our the value taking of values for the elements gets completed. So now we have to we have to know the right and left children of any node. Also, we should find the parent of any node. For that, we use a function, or you may say different functions. So, I use three functions. First, for the parent, second, for the left child, third, for the right child. So, for that, first, I show a message to the user whose parent or whose left child or whose right child he wants to get. So here I use printf message again, and here I type enter the index whose whose parent you want to know. Enter the index whose parent you want to know, and seeing this message, the user will obviously will enter a number, an integer, and for that I use a scanf function again to store the value entered by the user. Percentage comma ampersand, and here for that I have to use one more variable. Suppose it is x, so here will be x, and we thereafter we use a parent function. Obviously here this function is of return type, here parent, and here int. So the function parent has been declared. Thereafter here I call the function, and I take one more variable p for the parent. So here p equals to parent, and inside this x, the integer entered by the user. So I have called the function parent x, and now we have to define this function as well. Here for that purpose I am defining the function, here will be, you can take any variable, I take the same, and inside this I return the formula of the parent is, I have already uploaded a video for the formula to get the parent. The parent index will be x minus 1 by 2. Now this parent function is complete, and here I type a condition, if p is less than 0, that is if it is negative, then we type a message, index starts from 0, so there must not be a negative value. If it comes, then we say that there is no parent, there is no parent of percent %d, that is, and at the place of this will be ad. Okay, and one more thing I have to add here, that I have to I must type one more condition. It may happen that a user may enter beyond the limit any number beyond the range. Range means, for any array the indices are from 0 to size minus 1, and it may happen that, suppose there is an array of size 5, and it may happen that the user by mistake enters 10. Obviously this 10 is out of range. For that I type a message, if if x is greater than n minus 1, then we type a message, print f the entered number is not between 0 and percent %d, and here percent %d means n. and it is the case, then there is no need to execute the remaining parts of this program, and so we exit. So here I use exit function, and here I type 1, and you must remember that this exit function works only when you type an additional header file, and that file will be include stdlib.h. You have to type this additional header file for the exist for this exist function. Now also there may be a case if if x is less than 0. In that case as well, there is no need to find to there is no need to find the parent, left child or right child, because array index starts from 0. So here we must have to type the same thing with some modification. So here I put 2, and the remaining message will be the same. Okay, now since with this program I have to find the parent, left child and the right child. So these three things, parent, left child, right child, I type inside a single function. Here I introduce, here you see there is parent, only parent have been typed here. I type here parent oblique left child oblique right child. Okay, now here I type else part, else, and here I print the, sorry, there will be printf function, and here will be the parent of the entered index. that is percent that is percent d is percent d. And there are two format specifiers in this printf function %d. The first exists for this one and the second exists for this. Okay, now it is okay. Now we go for the left and the right child. For that we use a function named left child, and in the same way there will be a right child. So I type here left child, here int, and below this int right child, and here in the same int, and since I have taken p for the parent, accordingly I take l for the left child and r for the right child. Okay, since I have called two more functions, left child and right child, accordingly I have to call these two functions, and here I call l means left child, and here I pass x. Since I have called the function left child, so I have to define this as well. So I am defining here int left child, and here I use the same variable x, and below this there will be a definition. In that return, you see the function, these three functions are of return type because I have used here int. You see the same int, so I return. And you know the formula for the left child was 2 into I means index number, here index is x, minus, sorry, plus 1. This was the formula. Okay, now I here I am writing again, if this L is greater than the size minus 1, this index, the last index, then there will be a message, and that message will be printf there is no left child of percent d as it is a leaf node. Leaf node. Leaf node. This is the message. If the index goes beyond the size minus 1, and here inside this I have used percent d, so here will be a l, sorry, x, because entered number is x. Accordingly, I do the work for the right child, and for that here I type r equals to, thereafter I call the function right child, and I pass the same number entered by the user. And since the function is of, since I have called the function, so I have to define this as well, int right child, right child, and here will be int x. I take the same variable, you can take different one, and here I return, the formula to get the right child was 2i plus 1, sorry, 2i plus 2, and here for the I, the variable x stands for the I, so I type x at the place of I in the formula, and here will be 2, here will be semicolon to terminate the statement, C statement. And now the same message should be written. There will be a little modification, I will show you. Here I copy, and thereafter I paste here. I have pasted, and here since we are working for the right child, so here will be r, and here accordingly will be right, and in case of right child, no right child, this is not necessary that that will be a leaf node, so I have to erase this thing. Now our program is and here will be the else part, and here will be a message for the left child, print f the left child of the entered index is percent %d, and here will be a l, and here will be semicolon, to terminate, and accordingly here as well there will be an else part, and similar thing will be typed here. So I copy and paste, but there will be a little change. You will see, copy, here I paste, I have pasted, and here will be at the place of left it will be right, and here at the place of L this will be R. So our program, it seems that our program is okay, and I repeat again, this program is about, this program is to get the parent, left child and the right child of a given index, entered index by the user. I run this program, let us see it is working or there is some silly mistakes. It says to save the program, so here I save in the name of parent comma left comma right. Okay, here it says D was not declared in this scope, line number 18. Yes, here will be, you see this exit function, and you know to end a C statement we must use the semicolon. Okay, and after that one more error is there, D was not declared in this scope, line number 20. Oh yes, here will it will be P, because the variable P stands for the parent, not D. Okay, let us run this again. Yes, it is working, but I have to see whether it is giving us the parent, left child or right child or not. Yes, it says enter the size. I press 5, so I have to enter 5 numbers, 5 integers. I have entered 5 integers. Now I press the key enter. Now it says enter the index whose parent, left child, right child you want to know. Since I have taken the size 5, so I have to enter from from those integers which lies between -1 to 5, that is 0, 1, 2, 3, 4 etc. So I here, for example, you may type any number, I type 1, and thereafter I press the key enter, and you see enter the index whose left child, right child you want to know. I inserted 1, and the result, you see the result, the parent of the entered index, that is 90, is 34, and here is the left child of the entered index is 8, the right child of the entered index is 45. So the answers are 90, 8 and 45. The parent of the entered index, I have entered 90, but its parent should be 34, but it is not giving the right result. Let us check the program again, and you see the outputs are in a single line. So I have to place backslash n so that outputs, the three different outputs, parent, child, right child, left child, be in three different lines. Okay, so I do certain modifications. So the first modification I make here, I type backslash n, backslash n, backslash n, backslash n, backslash n, and this was not giving the right answer. So we should check this. Okay, here will be backslash n, backslash n to see the outputs or the message in the different lines. Okay, I execute this program again. Here I magnify. Okay, I magnify 400 times. Now you can see this clearly. Okay, now it says enter the size. I take the same size 5, so I have to insert 5 elements. Now it says enter the index whose parent, left child, right child you want to know. I place 3. Now see, the parent of the entered index is 56. 56 is 67. Okay, there is no left child of 56 as it is a leaf node. There is no right child of 56. Okay, I have left. I have not written backslash n for one more printf function. So I check that again. Here you can see that is 2. I have not typed backslash n. I type backslash n here as well, and I run this program again so that our outputs may be in different lines. Okay, enter the size 5, 5, the same size, 12, 45, 2, 90, 34. Okay, now I have taken 34. Okay, I have taken, so I take here 3 and I press the key enter. Now see, this is the output. The parent of the entered index is 90 is 45. So our first answer is 45. 45. There is no left child of 90 as it is a leaf node. Okay, and the same answer, there is no right child of 90. So here you see the index, you see 3 and 3 is about 90 because index starts from 0. Here 0, here, and 1 for this, 2 for this, and 3 for this. So it is okay. Index of 90 is 3. Now I verify this result separately. Here in this let us verify the result given by the C program. So the array elements was, first was 12, the second was 45, the third was 2, this was the third, 2, fourth was 90, fourth was 90, and the last one was 34. And you know the index starts from 0, so here will be 0, this 1, and here 2, here will be 3, here will be 4. So you see here the index entered, here you see the index entered was 3. You see that 3 here, you see the 3, you have entered 3, and accordingly here 3 stands, you see here this 3 stands for 90. So you see the parent of 90 is obviously 45. So first answer is 45, and there is no left or right child of 90. So accordingly we got the answer here, here the parent of the entered index is 45. Okay, it is 2, and there is no left child of the 90. Obviously there was no left child, as it is a leaf node, and since it was a leaf node, so there is no right child of 90. So our program is running well, but the viewer should verify different, taking different array size, taking different index. Only then he must be sure that this program is running well or not. Now once more I show you the entire program so that you can practice yourself in your home. And here is the entire program. You see, you see, I show you. I slide. You can see the entire program by pausing the video at different moment or moments. And this is the last part of this program. Okay, thanks.